Discover the secret of hidden fossils. How do fossils really form? The surprising truth. Have you ever wondered what it really takes to leave an eternal mark in stone? It is not enough to simply die. To become a fossil, it takes a perfect interlocking of events, a geological symphony in which every note is in the right place. Yet, as extraordinary as this is, the Earth is littered with traces of the past. Millions of creatures who have lived and died over time have left their mark in the form of petrified bones, shells, and footprints. Today, as we coexist with quintillions of life forms, we continue to discover the remains of forgotten existences. Fossilization, however unlikely, still happens. And from this unlikely miracle, an entire industry has been born, the fossil industry. But here's a curious detail. Despite the immensity of creatures that have existed, most of the discoveries are strangely familiar. Often, what emerges from the rock is something we have seen before, or a slight variation of something known. Sometimes a new dinosaur is found, sure, but it is often just a variation of a group already known, such as hadrosaurs. Rarely, however, does something entirely new emerge. And yet it happened. Some creatures found underground have thrown the entire scientific community into a perplexed silence. Among them, none is more emblematic than the Tully Monster, nicknamed Tully Monster, an affectionate name for a being so bizarre that it defies classification. Its appearance was surreal, an elongated cigar-like body, triangular fins, protruding eyes on long stalks, and a proboscis-like mouth, an animal worthy of an underwater nightmare. It was discovered in 1966 by an amateur collector who was exploring the Mason Creek Formation in Illinois. During his explorations, he found several fossils, clearly organic, but so strange that they did not resemble anything known. He took the finds to the Field Museum of Natural History, hoping for an enlightening answer. But even the most authoritative scientists were astonished. The creature's anatomy defied all logic. The body, without any real precedent, seemed to have come from an alien world, an aquatic creature of incomprehensible features, less than a foot long, but long enough to inspire fear with its disturbing appearance. This creature did not resemble anything known, not a mollusk, nor an arthropod, nor a vertebrate. Every attempt to classify it produced only conflicting hypotheses. Some ventured that it was a worm, others a tunicate, still others a conodont. The one thing everyone agreed on was that it was aquatic. And indeed, hundreds of millions of years ago, the Illinois prairie was a shallow tropical sea, its muddy bottom holding the secrets of creatures never seen since. The Tully Monster is thought to have been a free-floating marine organism, not anchored to the ocean floor or to fixed structures, sometimes carried by currents to the shores where its remains accumulated. Yet, despite decades of analysis and debate, we remain almost at the starting point. Today, we only know that it belonged to the bilaterians, a broad category that includes 98% of animals, making the classification virtually useless. Occasionally, someone has claimed to have deciphered its mystery, but no theory has ever stood the test of time. However, something has become clear. That very particular mouth seemed to make it a predator, perhaps accustomed to hunting in the middle of the water column, preferring muddy and poorly lit environments. But beyond this, the Tully Monster remains an enigma. And while scientists are puzzling over a single specimen, other even stranger fossils are popping up in equally unsuspected places. In the 1970s, another disconcerting fossil was found in Montana, so much so that it was nicknamed the alien goldfish. It was Typhloesus, an organism dating back to about 330 million years ago, which emerged from the limestone formation of Bear Gulch. Its slender and tapered shape, a single tail and small size, suggested that it too was a free swimmer, like the Tully Monster. However, the anatomical details only added to the mystery. Lacking external appendages, a recognizable midsection, or even an anus, Typhloesus possessed an internal organ never observed before or since, the pharaohesque, an iron-rich structure whose function remains unknown. The enigma was such that for years the fossil was ignored. Almost no one wanted to face the headache caused by its study. And when they tried to classify it among the conodonts, everything seemed to fall into place, at least for a while. A new discovery had shown that Typhloesus had teeth similar to those of conodonts, primitive jawless vertebrates, and this seemed to solve the mystery. But the illusion was short-lived. It turned out that the teeth did not belong to the animal at all, but to its latest prey, preserved in the digestive tract. Suddenly, we were back to square one. The only certainty was that it was a carnivore. And for 30 years, no progress was made, until in 2022, an unexpected statement shook the scientific community. Typhloesus could have been a mollusk. The hypothesis was born from the observation of a toothed tongue capable of shooting out directly from the viscera to strike the prey, an alienating mechanism but also present in today's mollusks, through the raduli. However, there was a problem. Similar structures had evolved in other non-molluscan organisms. Once again, all certainty was dissolved. The mystery remained unsolved. But Typhloesus was not the only puzzle to emerge from the Mazon Creek Formation. In the same place, two even more enigmatic fossils were discovered, so much so that they could only be identified by two letters of the alphabet, H and Y. These were Adakistus and Esmasia, creatures that defied every attempt at classification. Adakistus, the so-called H animal, was perhaps the most bizarre. Its body seemed to form an H, with a central protuberance of changing shape. In some specimens it was round, in others heart-shaped, in others completely indefinable. This suggested that it could grow and change throughout its life. Some scholars have suggested that Adakistus was a colonial animal, feeding by filtering particles suspended in water. It was even suggested that it was related to the Hemichordata, a family that includes acorn worms and similar animals, but no theory could fully explain its shape and behavior. It was just too weird. The Y-shaped fossil Esmasia seemed less disturbing than its alphabet companion, but it proved far more taxonomically problematic. Its body vaguely resembled that of a sea anemone, but with substantial differences. It was bilaterally symmetrical, had a complete digestive system, and surprisingly, a real anus. These features were enough to exclude it from the Cnidarian family. The mouth, a huge slit between what appeared to be two arms, added to the confusion. What those arms were remains a mystery. Perhaps limbs, perhaps simple extensions. Yet what is even more intriguing is the fact that these beings, although unknown and incomprehensible, resemble life forms that we might encounter in a tropical aquarium. As if nature, in a remote era, had experimented with infinite possibilities, many of which have been erased by time. But some traces, fortunately, have remained. If you think that the mystery has reached its peak, wait until you know what emerged from the ancient Ediacaran. In this remote period between 635 and 538 million years ago, macroscopic life left for the first time evident signs on the rock. Among these entities, one in particular defied all logic. It was called Namalthus. It looked like a tree made of flesh, a hybrid between a sea monster and an alien sculpture. Its body, initially mistaken for a trunk, was actually composed of calcified material, the oldest known example of a skeleton. But it doesn't end there. Later fossils showed that it was covered in grasping tentacles and spines arranged in menacing rows. Making it even more disturbing were the mysterious openings on its top, biological windows of various shapes, hearts, moons, hexagons, filled in life with organic matter. No one knows what they were used for, but the thought alone is enough to trouble the imagination. As if that were not enough, Namalthus possessed an uncanny ability. It could adapt its size to its surroundings, popping up in unthinkable places, even in the abyssal depths. There, far from the light, it lived undisturbed, camouflaged in the shadows of the primordial ocean. Some paleontologists have tried to compare it to corals, but the complexity of its structure made it too sophisticated for such a classification. It was alive, no doubt, but what exactly it was remains a mystery, and like Namalthus, many other Ediacaran life forms still defy comprehension. Take Dickinsonia, for example, a creature that looked like a bath mat but could move. Or Vendia and Spinia, beings of imperfect symmetry, grouped in a category called Proarticulata, creatures that look like animals, but who may have been dead branches of evolution, biological relics without heirs, coming from an era where the logic of life was still in the experimental phase. But if you think that the past has exhausted its mysteries, there is an even more remote era that overturns all certainties, the Rhyasian, dating back more than 2 billion years. It is here, in the heart of Gabon, that the so-called Francevillian biota was discovered. A collection of fossilized structures so strange that we don't even know if they were alive. Some look like discs, others like tubes, still others like strings of pearls or deformed flowers. Initially, they were thought to be colonies of eukaryotic organisms, but others hypothesized simple inorganic formations. The site was so ancient, more than 400 million years older than the previous record, that any interpretation was risky. Only recent studies, thanks to the isotopic analysis of their zinc content, seem to suggest a biological nature. If so, these forms did not swim, but lived suspended in the warm waters of a primordial delta, an eerie beginning for the history of life. That said, thank you and see you next time.